Welcome to NextEd by Nexaspaces, your learning space for embedded systems and IoT. In this module, we're exploring sensors, actuators, and data acquisition, the essential building blocks of smart devices. Today's topic is reading sensor data in real time. Let's see how embedded systems capture and process live data to make intelligent decisions. Imagine a smart greenhouse that automatically adjusts its temperature, lighting, and humidity levels, all without human intervention. How does it know when to act? The secret lies in real-time sensor data. In embedded and IoT systems, reading data in real time means continuously collecting information from sensors, processing it instantly, and making quick decisions, whether it's turning on a motor, adjusting brightness, or sending a notification to your phone. In this video, we'll explore exactly how embedded systems achieve this, how sensors send signals, how microcontrollers interpret them, and how we can visualize that data live. By the end, you'll understand how real-time data turns simple devices into intelligent, responsive systems, the foundation of every smart technology around us. Let's begin by understanding what real-time data really means. When we say a system works in real time, it means there's no significant delay between sensing and responding. For example, when you press a touch sensor on a smartphone, the screen reacts instantly. That's real-time response. Similarly, in IoT, temperature, pressure, or motion sensors constantly send signals to a microcontroller, which instantly interprets them and decides what to do next. In technical terms, the system must sample sensor signals at a high rate and process them fast enough to meet timing constraints. If a system reacts too slowly, it's no longer real-time, it becomes delayed or non-responsive. Real-time data acquisition ensures that decisions are based on the most recent and accurate sensor values, making it critical in areas like robotics, automotive control, and industrial automation. Now that we understand what real-time means, let's see how sensors actually connect to microcontrollers to provide live data. Sensors come in two main types, analog and digital. Analog sensors output a continuous voltage that varies depending on the physical quantity measured. For example, a temperature sensor like the LM35 changes voltage as temperature rises. To read this, the microcontroller uses an ADC, an analog-to-digital converter, which converts the analog voltage into a digital number that can be processed. Digital sensors, on the other hand, communicate using digital communication protocols like I2C, SPI, or UART. For instance, sensors like DHT11 or BMP280 send temperature and humidity data in digital form, reducing noise and improving accuracy. The choice between analog and digital communication directly affects how fast and accurately the system can read sensor data. In real-time systems, we often choose interfaces like SPI for speed or I2C when multiple sensors need to share data lines efficiently. Proper wiring and grounding are equally important. Even a small error in wiring can delay or distort sensor readings, affecting real-time performance. Now let's look at how real-time data is captured in code. In most embedded platforms, such as Arduino, ESP32, or Raspberry Pi, reading sensor data involves continuously sampling values inside the main loop. For analog sensors, we use functions like analog read. For example, int sensor value equals analog read, A0. Float voltage equals sensor value asterisk, 5.0/1023.0. Serial.println, voltage. Here, the ADC reads the voltage from the sensor, converts it into a numerical value, and prints it out in real time to the serial monitor. For digital sensors like DHT11, we often use ready-made libraries that handle communication protocols. Example, float temp equals DHT.read temperature. Float humidity equals DHT.read humidity. To maintain real-time behavior, this code runs continuously inside a loop, or, in time-critical cases, inside an interrupt service routine, ISR, that triggers automatically at specific intervals. Using interrupts ensures that sensor readings are not delayed by other processes. This technique is vital in systems like heart rate monitors or motion detectors, where even a fraction of a second delay can affect results. Reading sensor data is just the first step, the next challenge is visualizing it in real time. Data visualization helps us understand trends, verify sensor accuracy, and make informed decisions. In embedded systems, one of the simplest tools for this is the serial plotter in Arduino IDE, where values from sensors are displayed as continuously updating graphs. For IoT-based projects, platforms like ThingSpeak, BLYNK, Node-RED, or Adafruit.io allow live data streaming to the cloud. These platforms can plot your temperature, humidity, or motion data on dashboards accessible from anywhere in the world. Visualizing live data also helps in debugging. You can see whether the sensor is responding instantly or lagging, whether values spike unexpectedly, or whether communication is stable. It's like giving your system a heartbeat monitor, letting you observe how your sensors perform in real time. Real-time data reading is at the core of every modern embedded and IoT application. Wearable devices like fitness trackers monitor your heartbeat and steps continuously. Smart homes adjust temperature and lighting based on live sensor readings. In industries, sensors track vibration and motor health to predict failures before they occur, saving time and money. All these systems depend on fast, continuous sensor data acquisition, processed by microcontrollers and sent to actuators or cloud servers instantly. In the next videos of this module, we'll move a step further, exploring how actuators respond to this data and how control systems maintain balance and precision in real-world applications. Remember, sensors provide the eyes and ears of a system, and real-time data gives it awareness. Together they make IoT devices intelligent, adaptive, and alive. Thanks for watching this episode of NextEd by Nexaspaces. If you found this video helpful, don't forget to like, share, and subscribe for more deep dives into embedded systems and IoT. Stay tuned for our next video, Actuators and Real-Time Control Systems. Until then, keep building, keep learning, and stay connected with Nexaspaces Tech Education.